Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create a counter for retail store, the people who is basically entering and exit from store. So our goal is to create a counter for counting people frequency. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to create a counter for retail store enter and exit people frequency. So for that you need to simply open Python IDE and go to the tools, then manage packages, and just search for OpenCV-Python and just hit enter. OpenCV-Python, click on install. It will install OpenCV-Python. Then we need here CV zone package, so just search for CV zone, hit enter, and it will install CV zone package. The first package, click on it and it will install CV zone on our Windows machine. This is Windows 11. You can use your Windows 10 machine also. So for today's session we are going to use here normal OpenCV image processing, we can say image processing code. So for that I have created a new repository, people counting retail store. So inside that I have mentioned the code, the video file, and our tracker.py file, which with the help of tracker.py, of course, we track the object. So let's just download our repository. I will mention the link inside the description box. Copy paste the link inside the browser, then go to the code, click on download zip, and it will download our repository. So it's now downloading. So friends, as you can see, we successfully download our repository. So let's just open file manager, downloads. This is what our repository, WinRAR, and extract with the folder. This is what our folder, again same folder. And first let's just open our video file. Let me close the web browser and minimize the Thony. So this is what our video file in zip format. Right click, WinRAR, and extract here. It will extract our video file. So store.mp4, and as you can see friends, this is what our scenario. We have here a door, and this is the retail shop, and people are basically entering the shop and exit from the shop. So this is what our main entrance. So our goal is to create a counter for entrance and exit monitoring, the people frequency we can say. So for that we are going to use here simple image processing OpenCV Python operation. So as you can see, entering and exit. So this is what our video. So I hope now you know what we are going to learn in this session. So let's just open our test.py, which is our main code, and let me first comment some code here, and then I will explain full code step by step. So let's just comment this line also. Okay, so import CV2. Of course we are going to import here CV2. Import numpy as mp. From tracker import all the things, because we have our tracker.py file. If I open our repository, this is what our tracker.py, our tracker which we are going to call for tracking our object. So in this scenario we have our object is basically person. So this is what our tracker file. So from tracker we are going to call our tracker file in our test.py file. So from tracker we are going to import all the things, then import CV zone. This is the CV zone library for putting our counter on our frame, then import time. Then in today's session we are going to use here background subtractor, which is CV2 create background subtractor mock2. And I forget to mention here, for background subtractor mock2 we want to install here OpenCV-contrib Python package also. So our packages is basically OpenCV Python, then CV zone, and then OpenCV-contrib Python. The three packages which we want for this project, OpenCV-contrib-Python. Just click on it and install. It will install OpenCV-contrib Python on our Windows machine. So as I mentioned, we are going to use here cv2.create background subtractor mock2. It will subtract our background, and the history we are going to use here for this particular scenario. We need a 200 as a history, and threshold is basically 140. And this coordinates is basically changes as per your scenario. It's completely depend on what is your scenario. So for this scenario, I have mentioned history 200 and var threshold is basically 140. Then video capture is equal to, this is what our cv2.video capture, this is how we read our video file. So we want to mention here our video file. So let's just mention in double quote store, I think the video file name is store.mp4. Yes, store.mp4. So this is how we read our video file. And then if you watch my old videos, then you definitely know we have here a mouse function for basically drawing, or we can say for selecting our region of interest area. Because if we want to select some area where we want to track or where we want to detect our object, we want to select that particular area. So for that we need a coordinates. So for getting the coordinates, most easy way we use here cv2.eventMouseMove function. So with the help of cv2.eventMouseMove function, we will get the mouse cursor xy coordinates. When we move our mouse on the frame, inside the shell we have xy coordinates. So for that we have here this function, this, as you can see, the cv2.eventMouseMove function, which basically provide us a mouse cursor movement xy coordinates. Simple. Then cv2.name window, we want to create here a window, and cv2.set mouse m capital c capital callback RGB and RGB. This is how we call our mouse event function. That's it. Then tracker is just a variable. Tracker represent our tracker class which we have inside our tracker file. As you can see, the T is capital, so I have called here a tracker class from our tracker.py, as simple as. Then this is the area. So we will basically come after some time for this code area. So let's just scroll down, and while true, this is how we read our basic code, not big code, this is how we read our video file, video capture.read. This is the variable, where it is here, as you can see, video capture, and dot read is basically read our video frame. Then if when the frame is over, means when our video file is over, our code will be break and the window will be destroyed. For that, if they are not read, we are going to break our while loop, as simple as. Then we want to resize our frame. So we have here 1028 is basically our width, which is here, and 500 is basically our height. So this is how we resize our frame as per our requirement. Simple. Then we have here, after that we have here cv2.imshow and RGB. RGB is basically our window name. Here it is, as you can see. For mouse callback function, we create a separate window which is cv2.name window. So window name is RGB. So if we want to use here a mouse callback in same window, so we need to call this window name same as here. Here it is, as you can see, RGB. Then we want to call our frame variable. That's it. And then of course we have our frame on our screen. Simple. So as I mentioned, this is the basic code. This is how we read our frame. So for object detection purpose, we are going to use here cv2.create background subtractor mock2, which basically subtract our background and highlight the object. So that's why we have here bg subtractor is basically the variable. You can mention here any variable. This is just a variable which represent our background subtractor mock2. So we want to call our subtractor. So after where we resize our frame, after that we want to create a mask variable, because the subtractor will be mask the background. So mask is equal to bg subtractor dot. We want to apply our subtractor on where? We want to apply our subtractor on our frame. As simple. So bg subtractor is just a variable. As you can see, from bg subtractor we want to mention here dot apply. It will apply our subtractor mock2 on the frame. Inside that we want to mention the frame. Then now we have our mask frame. Now we want to apply simple image operation, which is cv2.threshold. So first channel empty, mask is equal to cv2.threshold. We want to mention here our mask frame and 245 and 255. This is the coordinate. And then we are going to use here cv2.threshold binary method. Then now we use a threshold method. So we have now contours. So simply we want to measure contours, and the next channel is empty, cv2.find contours, and then the mask, our frame mask, we want to mention over here mask, and then this is the basic operation for contours. So cv2.retur external and cv2.chain approx simple. This is how we will get the contours of our object. Then for cnt in contours, we want to call a for loop for our contours. Then area is equal to cv2.contour area. We want to mention a cnt. So for this particular scenario, I have mentioned the area. If it is greater than 1500, then we are going to draw the contours. Simple. And with the help of now cnt, cv2.bounding rectangle will give x, y, w, h coordinates. So x, y, w, h basically the coordinates for drawing the rectangle. So now we have x, y, w, h coordinates. Simply we can draw a rectangle on our frame. Simple. So this is basic operation. This is basic image operation. With the help of this image operation and contours and our subtractor, which is create background subtractor mock2, with the help of all these operations we will get x, y, w, h coordinates, and with the help of these coordinates simply we can draw the rectangle on our object. Basic operation. Now we have our x, y, w, h coordinates. So we have done with object detection. Now we simply want to apply our tracker. So if we want to use our tracker, we want our object rectangle coordinates which we want to send as a list inside our tracker. So for that x, y, w, h we want to create here a list. Simple thing. So list dot append, this is how we append our list, and inside that we want to pass our x, y, w, h coordinates. So x, y, w, h is here, and then we want to mention here list is equal to empty list. That's it. So now we have our list. Now simply we can update our list inside our tracker. So bbox idx is just a variable, and here it is. As you can see, we have here tracker variable, the tracker variable which represent our tracker class. Here it is, as you can see, the tracker class, and inside a tracker file we have tracker class, also we have update function. So this is how we call our update. So here, as you can see, if we want to use our tracker, we want to call our tracker variable which represent our tracker class along with dot update function, and we want to pass inside that our list, which is our rectangle x, y, w, h coordinate list. Means this is what our object rectangle coordinates means. We detecting our object. Now we want to send our object rectangle coordinates to our tracker, and again tracker will be track the objects and it will assign the unique ID for each person, because today's session our target is to count a person frequency. So our object is to track the person. So it will track the person. So of course it will track the person. So we have now again new rectangle coordinates with the help of tracker. Also we have the ID for each person. So we want to create here new coordinates, which is x1, y1, x2, y2 along with the ID, and all these things is basically our B box. Then we need here a center point for each object, because here we are going to select our area. Let me start a video file, just a minute. So this is what our video file. So this is what our scenario. So our goal is to not track the person everywhere, only in particular area. So let's just say when the person entering the shop, this is the area where we want to track the object. This is the area where we want to track the object if the object is basically exiting or entering in the retail shop. So for that we want to mention here, for that I have mentioned here, as you can see, a center point, because we are going to use here a point polygon test method. So when we say if our object center point in our selected region of interest area, then we are going to say I just want to detect my object, also I just want to track my object position, whether he is basically exiting or entering inside the shop. For that we need here object center point. So Cx is equal to int x1 plus x2 divided by 2, Cy is equal to int y1 plus y2 divided by 2. This is how we will get our center point. That's it. We done with object detection, we done with tracker. Now we have also our center point. Now come to the main point, which is how to draw a region of interest area. So simple. For that we have here, now let me start a polyline function. Also we have our area. Okay, so I have started all these things, and now we are going to basically freeze our frame. Let's just start our code. So friends, as you can see, this is what our final detection. So as I mentioned, we want to select here our region of interest area for detecting or for tracking our object in particular area. We don't want to track our object all over in retail shop, or we can say all over in this area. We want to only detect and track our object in this particular area. So for that we want to mention here our region of interest area. We can say the ROI. So for that I have used here cv2.polylines method, and for drawing polylines we need a coordinate. So for that we create a mouse event function. Here it is, as I explained already. This is what our mouse function. So if we move our mouse on our frame, as you can see, the mouse event is basically mouse move. So if we move our mouse on the frame, inside the shell, as you can see, there is continuously xy coordinates. If I go here, we have 91510 So if I go here, we have 22271 xy coordinates. So let's just say I just want to draw here a polyline. So simply I want to move my cursor over here, and then inside shell we have coordinates which is 214 and 166. So this is how I have mentioned the coordinates for drawing polylines. I have already mentioned it here, as you can see. Area 1 is equal to 213.165, 200.189, 693.373, 697.341. So this is our xy coordinates for drawing area 1, and this is for area 2. I hope you all clear. With the help of mouse move event function, we will get the xy coordinates, and you need to simply mention the xy coordinates like this way, area 1 and area 2. Simple. Now we have our region of interest area. So I have already explained here, when our center point, when our object center point, let me explain here. Let's just copy this cv2.circle method, and what we are going to do, here we have cx and cy. So if I start the code, now we detect our object. Okay, we detect our just a minute, cx and cy. Okay, that's it, no problem. So we detect our object, we track our object. Now we have our region of interest area, we have our center point. So if I skip the frame, over here, as you can see, this is what our object, the person, and it has a green color center point. So as I mentioned, we are going to create here a condition with the help of cv2.pointPolygon_test method. As you can see, cv2.pointPolygon_test method. Here we want to mention our area. So our area is basically cv2.polylines method. So cv2.polylines frame np.array area 1 np.in32 true. This is the color for drawing polylines, and this is the thickness. This is how we draw our polylines. So for area 1 and area 2. So if our condition is what? If the object center point, if it is inside our area. So if we want to mention our area, so our area is basically this function np.array. So simply cv2.pointPolygon_test, you want to simply copy and paste as it is. As you can see, I have copy and paste for area 2. Here area 2, here area 1. Simple. So just copy paste, and person center point is basically our cx and cy. So I have mentioned here cx and cy is equal to false. That's it. So let me comment now this circle method here. So now we create our condition. When the person center point, if it is inside our area, then only I just want to detect my object, or then only I just want to do other things. So when the person center point is inside in polyline area, we have 1. And when the person center point outside the area, outside a polyline, we have -1. So for that I have mentioned here, if the result is equal to 0, then only detect the object. Then only we want to detect object. So now we create our condition. So it means now our object is only track or only detect when our object center point inside our area. We have done. Now how to know that the person is basically entering or exiting? Simple. For that we create here 2 area. So let's just say, watch for this person action. The person is basically entering the shop. So first he will go through our area 1. This is what area 1, and then he will go inside area 2, and then he will entering the shop. So when the person enter in our area 1, in that time we want to save their coordinates and their ID. So here it is, as you can see, cv2.pointPolygon_test area 1 means our person is basically entering the area 1. So we mention here result is equal to greater than 0. In that time we are basically saving their ID and their current position. So person current position in our area is basically their center point, cx and cy. Simple. So ER is just a coordinate. ER, not coordinate, basically it is just a variable, we can say ER, and inside that we want to mention our ID, because if we want to say that this particular person is inside our area, for that we are assigning the ID, the unique ID. So ID is equal to their current position, and here I have create ER is basically the dictionary. So when the person enter in our area 1, in that time we are saving their ID and their current position. Let me print here ER here. If we print our dictionary over here, so as I mentioned, our dictionary is basically the person unique ID and their center point when the person is basically inside our area 1. So just start the code. So here as you can see, the person is not inside our area, so our dictionary is basically empty. As you can see, there is nothing. So if I skip a frame one by one, so now as you can see, the person is basically inside our area, and we have here 3 is basically this person ID, and 417 and 246 is basically the CX and CY, which we mention here, which we mention over here. As you can see, we mention here ER, ID and current position. So we have here ID and current position when our person is basically area 1. That's it. So now we have the idea that the person is basically already enter our area 1, because we saving their ID and their current position. So now we have their ID and current position when the person is basically inside our area 1. So now we can simply say that we have the ID and the current position. So we can simply say, if their ID is inside our dictionary, please only detect those ID who is already part of area 1, who is already enter inside our area 1, and now the same person is basically entering our area 2. Only count those ID, otherwise don't count, otherwise don't detect object. So this is how we can say the person is basically entering, because the frequency is area 1, first area 1. When the person, here let me show you here, when the person is basically entering, this is the frequency. So when the person want to enter the shop, first we will inside our area 1, so we are saving their ID and their current position. Then the same person is basically entering our area 2, so we can simply say we have the ID and their current position. So we can simply say only detect the same person who is already part of our area 1. So now he wants to part of area 2. So because of he is already part of area 1, so same person is basically inside our area 2, because we know that the ID is already part of our area 1. Simple. So this is our condition. And of course, if we reverse the condition, means the person want to exit from the shop, first he will part of area 2, we are saving their ID and their current position, and then he will part of our area 1, and then he will exit from the shop. So this is how we will get the enter and exit counter. Simple. So after that, as you can see, I have mentioned if the ID is ER for entering the inside the shop. So if the ID is inside our ER, then after we want to again call our CV2.pointPolygon test method, and as I mentioned, now we want to say our area 2, because when the person want to enter the shop, first he will part of our area 1. So we create the area 1 condition, means the person only detect when he is inside our area 1. We are saving their ID. Now he wants to part of our area 2. So same condition, if the result is greater than is equal to 0, then only we are going to detect all these things, the drawing the rectangle, putting the text, circle, and then we create a counter. So our counter is basically person unique ID, because ID is their identification. So counter 1.append, we want to append the ID, and here I have create counter 1 list format. And then of course when the person want to move from area 1 to area 2, in meantime the ID is basically continuing, means the same ID is basically count again and again. So for that we want to create here condition, please don't count same ID again and again. So if counter 1.count ID is equal to 0, means it will not count same ID again, and then simply we have a counter. Here it is, as you can see, I have created here a counter. So counter 1 is basically list of our ID. It will continuously saving each person ID as a list format. So the length of list is basically our counter 1, 2, 3. So enter is just a variable, length of our counter 1, and then I have mentioned CVZone put text method. It will put our counter on the frame. So same way as I mentioned, we are only going to reverse the method. First we will detect area 2, as you can see here, from here I have mentioned here, as you can see, the result 2 CV2.pointPolygon test np.array area 2. So from here we are going to start the counting process for exiting, the person who want to exit. So here first I have mentioned area 2, then same condition, if the result is greater than or equal to 0, then we are saving their ID and current position inside EX for the exit. So EX dictionary, we are saving their ID and current position. As you can see, I have created here EX dictionary. Then same way as I mentioned, if the person is part of our area 2 and same person who want to come inside our area 1, because we have their ID and current position, and then he will exit from the shop. So like the same way here, EX ID, CX CY, if the ID inside our EX dictionary, then we are going to say that the same person is basically inside our area 1, and then we are going to draw rectangles for exiting the person. And same way I have created here a counter. That's it. Now simply just save the code and run the code. As you can see, we have here counter, enter 0, exit 0. So let's just keep the frame. So this person is basically entering the shop. So first he will part of area 1, then he will part of area 2, and as you can see, as we mentioned, when the person want to enter inside the shop, when the person is basically in area 1, in that time no need to draw anything. But the same person, if it is inside our area 2, then we are drawing the rectangle, there is a center point and there is a unique ID. So this person, we have 3 is basically unique ID, and now he is inside our area 2, the same person who is already part of our area 1, and then we have counter 1. So we count here one person is basically enter inside the shop. So now simply what we are going to do, we are going to start our while loop, and then we have both side counter, enter 1, one person is basically enter inside the shop. Let's just wait. As I mentioned, other area will not count. So as you can see, the second person is basically inside. Third one, we counted 3 person is basically enter inside the shop. So one person exit, as you can see, exit one person. Now all this person is basically enter inside the shop. So we count 7 person. We count here 7 person who is basically enter inside the shop, and this is the real time method. I have mentioned the full code inside the repository. So I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.